All right. How's everyone doing? Good? Did y'all try that homework? Let's talk about it. What questions do you have? 25, yes. 25. 2x squared plus x minus 11, that one? All right. So number 25, we have 2x squared plus x minus 11. We're going to divide that by x minus 3. So we first have to make sure we recognize, what it is we're working with here, right? This is a polynomial divided by a polynomial. In fact, it's a binomial. Binomial on the bottom, but they're both polynomials, but this is specifically a binomial on the bottom. So it's not a monomial, therefore we have to use the long division, right? All right, so I set up my long division box here. Inside I put the numerator 2x squared plus x minus 11. Make sure it's in descending order, right? Don't forget that. Make sure it's descending order. Also make sure that there aren't any missing variables. Remember we talked about last time, if it went from x squared and then there wasn't an x term here, we would have to put a 0x, right? But this one, we got x squared, then we have x, then we have a number. So we're good, no spaces, right? Is that all right? Okay. Outside of this, we put x minus 3. Was it minus or plus? It's minus. And now what we do is we look at what two things? The x in front and the 2x to the second power in here. And we say to ourselves, what do I multiply x by in order to get 2x squared? So what do you multiply x by to get 2x squared? Yeah. You could probably sit like at the, yeah, and there's something like that. What do we multiply by? 2x. So I put 2x up here anywhere. And then we have to do the multiplication of that 2x times that. So I'll do that on the side. 2x, I'm going to distribute that through the x minus 3. When I distribute, I should get 2x squared minus 6x, right? That's my little scratch work on the side. I put that underneath 2x squared minus 6x. And then I'm going to come through and change the signs. So it'll become a minus 2x squared, and it'll become a plus 6x. And then go ahead and just add straight down now. If everything was done correctly, the first two terms should cancel, which they do. And then you have x plus 6x, which is, careful, you're adding. How do we add? It's 7x's, right? It's not multiplication, it's addition. So when you add the coefficients. 1 plus the 6 gives you the 7, the x stays the same. All right? So 7x, and then what else? Minus 11. And now I'm going to focus again on the x on the outside and the 7x down here. What do you multiply x by to get 7x? 7, positive 7. So that positive 7 is going to have to multiply through here. I'll do that on the side. 7 times x minus 3. 7x minus 21. That goes underneath. I come through. After I put it underneath here, I change the signs. And then add straight down. The first two cancel. Or the first terms cancel here, the 7x's. And then I have negative 11 plus 21, and that's 10. At this point, I can stop because I can't turn an x into a 10. So that's my remainder. So what we do is we go back up to the answer up here. I put next to the 7 up here. I put plus the remainder over, over what? The divisor, x minus 3. That is your answer here. Ooh, 51? Let's look at 51. 51's a pretty good problem. Did I answer the questions on that one? Okay. So on 51, we have 2x to the fourth plus x cubed plus 6x minus 17 divided by 2x squared plus 3x minus 1. All right, so we definitely have polynomial division here. We don't have a monomial on the bottom. We actually have a trinomial. So we're going to have to use long division here. My long division box, put it over here. Actually, leave a little space for a remainder if I get one. Okay. Inside the division box goes the numerator, and I need to make sure I put it in descending order and account for any spaces. Do I have any gaps in this one? Yes, I don't have an x squared term, do I? So I will have to add in here once I get to it. Here's the plus x cubed. Here's where the x squared would have gone had I had one, so I'll put plus 0x squared. And then I do have a 6x, and then I do have a minus 17. Okay, very important step there, to put that 0x squared in there. Now on the outside, I put my divisor, make sure it's in descending order. And with the divisor, you don't have to worry about gaps. I didn't talk about this, but on your divisor out here, if it had if it was missing one of those, you wouldn't have to put a 0 anything. That would be okay. Just on the numerator going into that division box. All right, how do I get a 2x squared to turn into a 2x to the fourth? I just need x squared, right? Okay, so x squared. I'm going to have to multiply that through to this. So that'll be my scratch work I do on the side here. I have to multiply x squared times 2x squared plus 3x minus 1. When you multiply that through, you should get 2x to the fourth plus 3x what? Third. Then minus 1x squared or just minus x squared, either way. Okay? That's going to be put, that right there is going to be put underneath this. So 2x to the fourth here plus 3x cubed minus x squared. Good thing we have a space for it, huh? Now switch our signs. Minus, this plus becomes a minus, and the minus here becomes a plus. See, I like over-exaggerate them so that you know they changed. And now go ahead and bring this down, add down, and what would we get here? Negative 2x cubed. That's all right. And then plus x squared. So on this one right here, the zeros are like it's not there. Okay, so you really just have whatever was here, x squared is there. You're not multiplying, you're adding. And if you add something to nothing, it's the same thing it was to start with. And then I still bring down that plus 6x, that minus 17. Okay, now, what do I multiply 2x squared by to get negative 2x cubed? Well, I need to turn a positive 2 to a negative 2, don't I? How do I turn positive 2 to negative 2? Multiply by negative 1, right? Negative 1. But then I also need an x, don't I, to get from x squared to x cubed? So I need a negative 1x, don't I? So you can either write negative x or negative 1x. It's up to you. Either way. I'll put it as negative 1x so everyone kind of sees that I need the 1 there. Is that all right? Now you have to multiply that times this. I'll do that on the side here. I'm going to do negative 1x, or just negative x, times the 2x squared plus the 3x minus the 1, which is negative 2x cubed, right? Negative 3x squared and positive 1x or positive x. Distribution, is that okay? Multiplying that negative 1x through. Now we put it back underneath this one right here. So we have our negative 2x cubed. We have a minus 3x squared. We have a plus x. But I have to come through and subtract this row, or change the signs, right? So that my minuses become pluses, my pluses become minuses. Adding straight down, first two cancel, then we have what? How many x squareds? 4x squared, and then plus 5x, and then bring down negative 17. All right. Now I need to see if there's any way I can turn 2x squared into 4x squared. Yeah. All I need to do is turn the 2 into a 4, and it's identical, isn't it? So how do you turn a 2 into a 4? Multiply times 2. So I'm going to put up here times positive 2, so I put a plus 2 up here. Top. And then that's going to be the 2 that distributes through, and we do it again, and we put it underneath, and then we should be at the remainder at that point. So let's see what happens. 2 in front of 2x squared plus 3x minus 1. Distribute 4x squared plus 6x minus 2. Do you all agree? I'll try and bring that down a little bit. I hope y'all can see that down there. Put it underneath, 4x squared plus 6x minus 2. Come through, change the signs, minus 4x squared minus 6x plus 2. The first ones cancel. What do we get on the x terms? Negative, just a negative x or negative 1x. And then minus 15. Negative 17 plus 2. Now we cannot turn an x squared into an x. So at this point we're done. We're at the remainder. That is our remainder. So what we need to do is we need to put all this up here and then plus next to it the remainder over the divisor. So my final part of my answer, I'll do plus up there. Negative x minus 15 over my divisor, which was 2x squared plus 3x minus 1. That's the answer. What do y'all think? No comment. No comment. We love long division, don't we? All right. Now, long division is actually very, very important. I mean, it's one of those techniques. You know, I tried to tell you last class. You know, where do you use this stuff? Did y'all ask that, or was that my other class? That was my other class. Why would I ever use this? I was talking to them about that, and you know, it's math at this level of math. You're learning a lot of different skills, and I try and equate it to, like, you know, teaching you how to use tools. If anyone's ever used, has anyone ever used a router? Okay. Has anyone ever used a saw, a hand saw? How many of you could cut a piece of wood with a hand saw right now? Okay, because you've probably seen that, right? How many of you know how to use a plunge router? Couple, right? So what I'm doing is I'm showing you how to use certain tools, right? Mathematical tools, And what happens is as you progress through math, then you start building stuff with these tools, but you can't build it if you don't know how to use it. And that's kind of what math is. That's why it's hard at your level to be like, well, why would I ever use this? Well, we're not building anything yet. We're just learning how to use the tool. So that's why I know it's hard for you to sit there and be like, this sucks. This is not interesting. Who cares? I won't ever do this. But if you ever had to solve some engineering problem, which I know a lot of you won't, but if you did, then this is something you would use. But then you could make the argument, well, then why do I have to learn how to write a 25-page paper if I'm going to be an engineer, right? Like, why do I have to take English classes and all this other stuff if I'm going to just be an engineer? So it's just the idea of getting an education, right? A general education. Yeah. We don't want to debate why it is that you have to do the things that you have to do to get a piece of paper, but that's what you have to do to get the piece of paper, right? And then you learn at the same time. Okay. I think I'm done with that. We're ready to move on to the next section. This will be the last section that will appear on the test. I think you're going to be pleasantly surprised that you're going to be happy to see it. It's going to be different than the long division, and most students like it a little more. So that's good. Be careful on today's date when you sign in. On the 25th, it's blank because I have not checked off your attendance from what you turned in the other day. So please, first person, sign in on the 27th, and everyone else, please sign in on the 27th. I know it's not going to happen. Someone's going to mess it up, but just try to remember that. Okay, sign in on the 27th. I will count you present from last time with the stuff you turned in last time. All right. So the next section we're doing, we actually jump to Chapter 7 just for one section. I think it's Chapter 7. It's like 7-4. What the heck? We are going to be on page 478. Synthetic division. Synthetic division. Now, 478. Now, if you tried to read through the instructions for synthetic division, you might just go crazy, all right? Yeah, well, I think math books are hard no matter what. It's a skill to learn how to read a math book. It's not easy to write math. I mean, it's a challenge to get it to just write on paper how to do something mathematically. It's tough. Okay, synthetic division. Now, this section, I'm actually not even going to assign homework out of this section because this section involves other things, but I will assign homework using synthetic division. So I'm going to give you problems and tell you use synthetic division to solve them. So what synthetic division allows us to do, it's like long division, right? Long division is a way of dividing. Synthetic division is another way of dividing, but it can only be used if you have this. Okay, so that's the first thing. Only use this if you have a polynomial divided by a binomial and more specifically a polynomial divided by something like, this is like an example, okay? A polynomial divided by something like x minus 2. What I want you to notice here is, you have two terms, right? That's your binomial. And for simplicity's sake, the problems that I'm going to do today, you'll notice that every one of the problems I do, you're going to have a 1 in front of this x, right there. That's kind of too big. A 1. If that's something other than a 1, you can do this, but it requires one little step at the beginning. Maybe at the very end of class I'll show you one that doesn't have 1, but most of the problems I'm going to focus on are going to have a 1 in front of x and then some number out here. Might be -2, might be +7, might be -20, but or even a fraction perhaps over here, but that's going to be just x, okay? That's the only time you can use synthetic division. So it's limited, right? It doesn't address if you have a polynomial divided by a trinomial. You can't use this. So you might be sitting there going, well, why show it to us? Well, it turns out later in college algebra that we will use this extensively to help us factor. If anyone's ever done any factoring before, this is something we will use as a secret weapon against factoring. Okay, so let me show you how it works. I was asked to do a problem at the beginning of class. This first one, this is a perfect candidate for synthetic division. So just look at this up here. Look at what we had to do to get it, right? This is what we had to do. I'm going to redo this problem using synthetic division. All right? So y'all can help me because I won't remember that. So here's your first example. We had 2x squared, that's all I remember. And then there was 11, right? Plus x. Minus 11. Over. Okay, that's what we had before. So we already know we can do this with long division. We can do it. Fine. Here's how you can do it using what's called synthetic division. And again, with long division, I just showed you how to do it, right? And then we just kind of got used to it. Synthetic division, same thing. I'm just going to show you how it's done, and then you kind of pick up on it. If I try and read through the steps of it, it's, like I said, it's confusing. So we're going to start off with a division box, just like before, but hold on. It's flipped upside down. And make sure you leave enough room here. We're actually going to write a row of numbers across and then a row of numbers underneath it. So we need 2 rows of numbers. So make sure this is a pretty big box. I can't draw a straight line for my life. Okay, now before what we did in the long division is we just put the numerator inside that box, didn't we? With synthetic division, you do not look at the numerator. What you do is you look at the coefficients of the numerator. Now, when I say coefficients, I'm talking about the numbers only, right? So tell me what is the number in front of the x squared term here? 2. What's the number in front of the x term here? 1. And what's the number over here by itself? -11, okay? Those are the 3 coefficients, aren't they? I'm going to put those 3 coefficients in the box, leaving space underneath each of them. Okay, so notice there's space under these. That's the first thing you do. The second thing you do is you look at the number after x, and you make sure you look at the sign too. You see the -3 there? You're going to take the opposite of that. Who's going to forget that on the test? Okay, the opposite of that number, all right? You're going to take the opposite of that number and put it right here. So what's the opposite of -3? +3. And just maybe make a little note there. Opposite of what was there. Now, had that been an x plus 7 up here or down there, if that was x plus 7, what would you have put here? -7. Okay? You all right with that? Okay, that's the setup of the synthetic division box. Now we just go through a procedure. Here's the procedure. You start with the 2 right here, that 2, and you bring it straight down underneath here. Just watch me do it. I'll draw little arrows. That 2 is going to come down and go below here. And that should always happen on the first step of synthetic division, is that first number will just drop all the way down. Now what you do is you take the 3 that's out here and you multiply it times this 2. So I'm going to do this with a very light line here. And I'm going to put a little m next to this for multiply. Is that all right? I'm going to multiply 3 times 2. What do you get when you multiply 3 times 2? 6, you're going to take that answer and you're going to put it up underneath this 1. Okay, so 2 drop down. 3 times 2 is 6. And then what do you think we're going to do now? Add down. Okay, so same thing, come down this column right here. What is 1 plus 6? So I'm going to draw an arrow coming down like this, and I'm putting an A next to it for add. 1 plus 6 is what? 7. That goes here, right? Now, what do you think you do? Multiply that 3 times 7 again. Now, this can start looking pretty crazy if I start having all these arrows everywhere, right? But I'll do it just for this first one. 3, and I'm multiplying here. 3 times 7 is 21. I put that, where do you think? Underneath the negative 11, 21. And then add straight down. Okay, don't have to change the signs or anything like long division. You multiply, put it there, add down. Multiply, put it there, add down. Multiply, put, add down. So add down. What's negative 11 plus 21? What is it? 10. Okay? Now what we normally do with synthetic division is the last number you get, okay, or whatever's out here, we draw a little, this is the way most books do it. They draw a little separator here. I don't know why they don't just box the whole damn thing, but most books will go like that, okay, put like this little L over it. That's your remainder. If you go back and look at the problem we did, right, what was our remainder? 10, right? Okay, we just got our remainder, didn't we? Now I want you to see something else. Look at our answer up here. There's 10, right? That's our divisor. What do you notice about this? How is this connected to what you have down there? Do you see the 2 and the 7? That's going to generate our answer. This 2 generates part of the answer. The 7 produces another part, and the 10 is our remainder. Okay? The question is, how do we know it's 2x? Right? How do we know it's 2x? Well, the way we do it, the way we know this, and this will always be the case, is what was the numerator when we started off? What was the degree? You all remember when we talked about degree? It was the highest power of x, right? What's the degree of the numerator? 2. Okay, your answer is going to be 1 degree less than whatever that was. Always. So you know your answer is going to start off with an x, not an x squared, 1 less power than 2. So it's going to start out with an x term, then the next term will not have an x, then the next term would be your remainder. And that's the pattern of what synthetic division allows for. Does that kind of make sense? Huh? As far as why would you use this, or like why it works? And, well, because you can get really, really fast with this. You can get really good at it. And without, with long division I think is one of those skills where it's like you've got to always have that to fall back on. But synthetic division is one of those things where it's like, I'll show you something real quick. Well, I'll get back to it. I've already drawn myself off this. This is a Cal 3 exam that I gave. Let me see if I can find this problem right here. Here it is. Look at this. Okay, look at the problem. It says find the values of b which makes these vectors orthogonal, and it's blah 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 blah. But look at what happened in the problem. The student had to do some division, polynomial division, and so they had to use synthetic division. So look, what they're doing is they're trying to use synthetic division until they get a remainder of 0. And you'll see in the next couple of sections why that's important. But no, it didn't work, and then here it worked. That's much easier to do than imagine taking that polynomial and dividing it and then having to keep track of all the x's. It's just a lot harder. Synthetic is super fast once you get good at it. So that's the advantage of it. At about my entire 19 students, not a single person used long division when they tried to do this problem. Every single one of them did synthetic. So just to give you an idea, it is useful. It's the preferred method if you can use it. But you can only use it when? When you have a binomial on the bottom that looks like this. So, okay. I hope that in some way addressed your question. Okay, back to this. So we have the 2. Now we know, again, that because the power up there was 2, we know that this first one is going to represent 2x. So I'm ready to write my answer below this. I use this information to write 2x, and then my next piece is what? A positive 7, so plus 7, and then my remainder, plus 10 over, now my divisor I know, it's x minus 3. Okay. That all right? I'm going to go back to your homework real quick and see if I can pick one of the problems that maybe you already did for homework. Let me see if I gave you one that we can now use synthetic on. Oh, yeah. How about number 21? So as this example, x squared plus 7x plus 10 over x plus 5. Okay. So can I show you something? And it's not showing off, but it's to answer your question. All right? Check this out. If I were asked to do this problem, here it is. 1, 7, 10, negative 5, 1, negative 5, 2, negative 10, 0. Answer is x plus 2. Okay? You see how quick that is? That's why. Now let's do that same thing. I'll go slow. Okay, first thing we need to make sure we have is binomial on the bottom. Okay, it looks like x and then the number. So I'm going to do an upside down division box. What numbers are going to go here? 1 is the number in front there. 7 and 10. So just be careful with the signs, right? Make sure you grab the sign, whatever it is. 1, 7, 10. What number goes on the outside? Opposite. Opposite of what you see. So negative 5. Okay, now you try it this time. Bring the 1 down, multiply over, bring it up, down, multiply, bring it up. See how long it takes you to do that. What's the remainder? 0. Do y'all see it? Anyone have a question on that? It's just going to take time to get quick with it, but more practice, the faster you get. Okay, so now let's talk about the answer. What was the degree of the numerator when I started the problem here? 2. So I know that my answer is going to have an x in it, not an x squared, right? X. So this should be, the 1 should be in front of an x. I don't have to write the 1, but I am. And then I should have a what? Plus 2. And do I have a remainder? No, so I don't need to write anything. So my answer is x plus 2. No, it wouldn't be wrong. All right. Questions? You like this a little better in long division? Okay, good. Hold on. Okay, we'll start with this. Yeah, that'll work. Can we use synthetic division here? Yes. Okay. What will go in my box? 1 and 8 or negative 8? Negative 8? What about the x squared? There is no x squared, right? What about the x? There is no x. So what do you think we need there? Zeros. That's why I'm giving you this problem. Because you're missing an x squared, right? And you're missing an x. So when I set up my synthetic division box upside down, I do need that 1, right? That 1 comes from the x cubed. But since I don't have an x squared, I need to put a 0 there. Again, it's like a placeholder. It's giving me a column to like we did when we did long division. Do I have an x term? No, so I need another 0. And then now I can put negative 8. Now let me show you if I take this over here and rewrite it, maybe this will help you. That can be rewritten as x cubed plus 0x squared plus 0x minus 8, right? That's the same problem right there. So now do you see 1, 0, 0, negative 8? See that? You have to have that. If you just put in the synthetic division box 1, negative 8 without the zeros, it's going to be wrong. Now, what goes on the outside? 1. Okay, see if you can do this one. Remainder? Negative 7, right? You should get 1, 1, 1, and then negative 7. I don't usually draw those lines. Can I stop doing that? Okay. All right. Here. There. They're gone. It never happened. All right. Let's talk about the answer. What's the degree of the numerator to start? 3. So ours is going to be x squared, right? So this first one tells me I have 1x squared, right? This one tells me I have come down 1 on the power, so plus 1x, come down on the power, plus 1, and then the last one plus negative 7 over divisor. So I could write x squared plus x plus 1 plus negative 7 over x minus 1. You were doing minus right here? Yeah. Because this would probably turn out to be a negative 1. Yeah. Is that all right? Questions? Why? What? Why didn't I? Where did this come from? Well, the 1 comes from here. The fact that it's x squared is because always in synthetic division, you need to put x's on these numbers. And the first number, the x that it gets, is whatever the top was, x cubed, but bring the power down 1. So if that was x to the 5th, this would be x to the 4th, okay? I'm going to give you one to try, and let's see if you, well, let me give you a couple to try, okay? How about this one? Try 3, we'll change the variable up. 3y cubed minus y squared plus 4y plus 10. I want you to divide that by y plus 2. We'll say that's problem 1. Problem 2, try 4a cubed minus 6a squared minus 8 over a minus 2. Try those two. If you're really getting good at this, try this one. Just so you don't have to sit there and twiddle your thumbs. I want you to do at least the first two. All right, I'm going to work through these very quickly, all right? All right, so the first one, my synthetic division box is 3, -1, 410. I saw a lot of that problem there with that -1. The opposite of the positive 2 on the outside. Then 3 comes down, multiply 3 times -2 is -6, add down -7. -2 times -7 is positive 14. Add down, you get 18. -2 times positive 18 is -36. Adding straight down, -26. The power on my answer is going to start out at y squared because the original problem was y cubed. So I get 3y squared minus 7y plus 18, then plus my remainder, 26 over my divisor, y plus 2. I know I went fast, but you can go back and watch it if you want to. Slow-mo. Okay, and now the next one. I noticed this got a lot of people, number 2, because we actually have a gap in here, don't we? We have a gap on the A. We don't have an A term, right? We don't have an A term right there. So the numbers are going to be 4, -6, and then here comes my gap, 0, and then -8. The number on the outside is 2, opposite of the -2. Okay, 4 comes down. 2 times 4 is 8. Add those down, 2. 2 times 2 is 4. Add down 4. 2, 8. I get remainder of 0. Now, the power is going to start out on squared because my original problem had cubed. So it's 4, and the variable is a, so a squared. Next one is positive 2. Power comes down a, plus power comes down 4, and there's no remainder. So we're done. And the last one. Last one, I'm actually going to squeeze this guy up top. Okay, this one we'll do up here. Now I have a lot of gaps in this one, right? I have a 1 in front of b to the 5th. I have a -1 in front of b to the 4th. Do I have a b cubed? No. Do I have a b squared? Do I have a b? What's the number in front of b? -1. And you can stop there. Now on the outside, -1, opposite of what was there. So then 1 comes down, that's -1. Add down -2. Multiply, negative times negative is positive. Add down is 2. Multiply -2. Add down -2. 2. Remainder 1. What's the power on my answer going to start with? B to the 4th, right? So I have 1b to the 4th minus 2b to the 3rd. Powers keep coming down. Plus 2b squared minus 2b. Now be real careful. That 1 was your remainder, wasn't it? So then I put plus the remainder over 1 over b plus 1. Is that the answer? No, something's off here. Hold on. Hold on. 1 over b plus 1. Did I leave off my 0? Oh, I left off my 0 for my constant term. Jeez. Hold on a second. Yeah, I know you're confused. Back up. There was one thing. Look at your powers again. Remember how we had the gaps? Let me come down here and show you. We had the 1 in front here, the 1 in front here. Then we had 0. Let me rewrite this. 1b to the 5th minus 1b to the 4th. Then we had 0b squareds, 0b's, right? B cubed, thank you. B cubed, 0b squared minus 1b, right? And then we don't have a number by itself, right? So it's really like a 0 out there. That's what I forgot to put there. A constant. The constant there is 0. Yes. That's what I had not put there. See, we're all human. So -1, 0. So 1, let me try this again. 1, -1, -2, 2, 2, -2, -2. What's that? 2. That's 1, -1. Our remainder is -1. Now we'll start 1b to the 4th minus 2b cubed plus 2b squared minus 2b plus 1, and then our remainder over our divisor. Okay. Sorry about that. One more type before we, well, we still have 15 minutes, yeah? Like it end. Well, in your synthetic division, you need to account for the last term being a constant. So if there is no constant term, then you need to add it in there. Yes. It doesn't happen a whole lot, though. Yeah. No. I brain farted on that one. Yeah. Okay. Next one. We haven't seen this yet, so I think now is as good a time as any to show you one with fraction. Why? Why? Why do we have to do fractions? Why? Well, the problems that you're going to have that would have a fraction in it, most of the time, they work out pretty nice, okay? Because they're specially made just to make you not want to go drop the class. They're just enough to make you not happy, but not enough to push you over the edge. Okay, but it's the same thing, right? We have a polynomial divided by a binomial. We have a 1 in front of that x. We can use long division, but we're going to try synthetic because we like synthetic now. So when I do this, what are the numbers that are going to go in here? 2 here, right? -5, 1, and 2. No spaces, right? No gaps. All right? And then now the number on the outside. Careful. Opposite of what you see there. -1/2. And don't break your calculator out. Let's just try and get through this, okay? The -1/2 comes from the opposite of what was here. All right, drop your 2 down. And now, what's half of 2? 1, but it's negative times a positive, which is negative, isn't it? So it's really a -1 when I add those two, multiply those two together? and I put that negative 1 here. Do you all follow that? Negative a half times positive 2 is negative 1. Now add straight down. What's negative 5 and negative 1? Negative 6. Okay, you're going to take half of 6, which is 3, and the negative times the negative is positive. So that should be a 3 there underneath the 1. Come down with that. Aren't these nice? These are all turning out to be even numbers when we bring them down, because now we can always take half of them. So what's negative a half times 4? Negative 2. And that, oh my goodness, and we have no remainder. It worked out nice, didn't it? So the answer is what? 2x squared minus 6x plus 4. Okay? I think you're ready. I think you're ready. This is it. As far as the material that would be on the test, this is it. We've done it all now, all right? So what's going to happen now? We talked a little about this last class. On Tuesday, what are we doing? Reviewing for the final shit. The final test before spring break is what I meant. On Tuesday, we're going to review for the final the test, which will take place on Thursday, and then you have spring break, right? Okay. Are you still coming by to get the review today? Okay. So I am actually going to put the review on the web. I'll send it. You know where we have our course files in Canvas. I will post it there, and you know I'll email it to you also. Okay. The review for the exam. So that way this weekend, if you want to start working on it, you can. All right? Yes. I will normally instruct you, but that's why you need to look at the review, because the review will be worded the same way the test will be worded. So if there's any confusion, we need to square that away Tuesday before the test. Yeah, now I should probably put a little asterisk next to that, because there is, I won't do the problem, okay, but let me go to something that would be iffy. I know y'all want to go, but just hang tight. There we go. Something from possibly your homework last time. Hang it, come on. Okay. Gosh, here we go. Here's an interesting one. It is going to turn out nice, yes. But check this out. What about 27x cubed plus 8 over 3x plus 2? This is like a bonus problem. Y'all like bonus problems, right? This would be like what you would see as a bonus problem on the test. Make it worth your hanging out here for a few more minutes. What do you notice right away? We have binomial on the bottom, but we have a 3 in front of that x, and that changes everything. You can still do synthetic, but you can't have a 3 in front of that x. So what I'm going to do is this, and this is the tricky part. 27x cubed plus 8. Tell me if you agree with this. Is that the same? Ooh, what the heck just happened? Just forget this over here on the left. Just look at this real quick. What if I took this 3 and distributed that 3 through? What would I get? 3x, and then what would 3 times 2/3 be? 6 over 3, which would be 2. So isn't that the same exact thing? Yes? Okay. If you believe that. So that's a trick. That's a little game I'm playing. I'm pulling a 3 out of this, actually. So when I pull the 3 out, it comes out in front, but then I have to divide this 2 by 3 in order to make it kind of cancel out when I go back through. Now watch what happens here. This is that 3 on bottom. I can separate it completely. Isn't that the same? A 3 down here, if I make it like a 1/3 out in front of that thing, that's the same? So that 1 would go across the top, wouldn't change anything. The 3 would go across the bottom, it would turn into that. So I've got the same damn thing up there, don't I? So this, in the red here, 27x cubed plus 8 over x plus 2/3, that's something that I can do synthetic division on. Because now what's in front of the x? A 1. You see that? Well, I'm going to have to bring the 1/3 in the very end. So please do not forget that 1/3 is going to be there. But we'll come back to it. Let's do synthetic on this. And now we're super quick at synthetic, right? 27, 0, 0, 8, right? And then what goes out here? Negative 2/3. 27 comes down. Take 27, multiply by 2/3. So divide it by 3 first. 27 divided by 3? 9 times 2, 18, but it's a negative, right? Because negative times positive. So negative 18. Add down, negative 18. All right, what's negative 2/3 times negative 18? Well, it's positive, right? Take 18, divide it by 3 first. 6, multiply by 2, 12. Positive. Add down, 12. Take 2/3, negative 2/3, multiply times 12. What do you get here? Divide it by 3 first, you get 4. Multiply by 2, you get 8, but it's negative, so negative 8. And you get 0. So your answer is 27x squared minus 18x plus 12. But that's just what that red part is, right? So now my final answer to what this green thing is over here is 1/3 in front of 27x squared minus 18x plus 12. And can you multiply through by 1/3? What's a third of 27? 9x squared. What's a third of 18? Minus 6x. And then a third of 12? Plus 4. Yeah. Where did I get the 1/3 from? It's just another way of looking at this right here, 3, that there's really a 1 on top of it out here, and just kind of pulling it out. I pulled it out so that the thing I boxed over here in red, I could look at it as its own problem, and then later on come in with the 1/3 in front. Okay, that would be a bonus problem, but I think it's doable for, you know. I would say do it with synthetic division. Because it could be done with long division, but I would want to see the that trick right there. That's the main thing, is that trick of pulling the 3 out. That's the bonus, is you being able to do that trick. Yes, yes, yes. What may not work out is the numbers may not be nice. Like notice every time I said 2/3 of this, it was always a nice number. Like if this had been a 7, 2/3 of 7 is, 14/3, and then you start getting fractions, carrying fractions through the whole time. It can be. I won't do that to you. On the test, it would work out nice. All right, I believe we're set, right? I gave you a homework assignment? No, I didn't. Almost got away. Almost got away. But the review is really going to be your main homework assignment. I told you out of 7.4 there wasn't anything, but then looking again, there were some problems that I think are good. It's all off of page 484 is where it starts. And I think if you're going to mess around with synthetic here, 11 through 27 odd, that's a good mix of problems there. 27 has a fraction in it, but it works out nice, just like the one we did in class. Okay? Check that review on your email. Have a good weekend. Be here on Tuesday to review. Sign-in sheet. Where did it go? Did anyone else need to sign in? No? Thank you. Wow, y'all did it. Perfect. See, are there any eraser marks? No?